KEET TV presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
Welcome to Homework Hotline. My name's Pam Halstead, and I taught science at Fortuna High School.
And I'm Ken Pinkerton, and I taught science at Zane Middle School.
We are science teachers!
Yes, we're still at it.
We have some very cool things to show you. Ken has brought an array of stuff to explode and to make light,
right?
etc. So we're looking forward to it. All right,
so
Ken,
today's
what
a
do you have?
combustible show is what we're doing.
It's about
so
combustion.
we're going to talk about combustion. And so combustion is a chemical reaction, and it's a really rapid combination of oxygen and a material and heat. So there is, if we can pull it up, there's the old graphic. It used to be called the fire triangle.
Yes.
There it is. That was
nice.
Oxygen, heat, and fuel. Mm-hmm. And now it's called the fire tetrad. That speaks, I think, more wisely,
sure
I guess.
For especially fires that we have in California, which are,
So the chain reaction is so involved in it. So. Mm-hmm. And so kind of keep remembering those reactions. So look for the chain reaction and how the oxygen comes in. And then with fires, if you want to stop it, you take away one of those elements. So you either take away the oxygen. That's why they use fire hoses, is to cover things up. You would think maybe it's to take away the heat, which it is partially. Mm-hmm. But it's more to stop, make a barrier between the burning material and the oxygen.
Yes, and the burning material almost always contains carbon, because carbon is one of the things that's going to combine with the oxygen, and that's what Ken said you need, to then cause this reaction, and then the reaction produces, strangely, carbon dioxide and water. Yeah. So that's sort of surprising. And if you put, or are we going to do it?
Go ahead. No, go ahead.
If you take a candle and you put something to cover it, and then you let the candle burn out because it doesn't have the oxygen, you'll see condensation, or you'll see some water vapor that has condensed on the sides of the glass container if you have something like that. So
we could try that.
Yes, we could.
I have a plastic container. I'm not sure if that was going to work or not. But
well, we just break the candle in half.
Yeah, that's true. That would be an easy solution.
Cool.
And then there's some neat things to see what actually burns, is that it's not like in this candle. I'm going to light the candle. It's not actually the candle that's burning. Mm-hmm. So we'll get it heated up. Oops. That's why I brought a spare lighter.
Yeah, sweet. Okay. There you go.
We'll let it get going. Mm-hmm. So it's I remember one of my coolest labs in middle school when I was a kid is we did a candle lab and just made observations. Mm-hmm. There's so much happening. There's crazy. There's little things floating in circles. You know, all the different things that are happening with the wick and all the different layers that are in the candle itself. And so one of the neat things you can do, I'll light my other one too, and we'll try that. This is a neat demonstration to show you what's actually burning. Mm-hmm. Let me get this one going. So I'm going to snuff it out with my little snuffer here, and then. So if you watch, if the camera crew's doing an awesome job, is that you can see that the flame actually jumps down. He's
not touching the wick at all.
No, not at all.
No.
And sometimes you can see it. So I was at least an inch away.
Is that the wax that is burning?
Yeah, so it's the smoke. If you look, you can see the smoke is catching fire from there. Because if I let it go, we'll let the smoke completely go away. Maybe.
Yeah, it might take a little longer than we knew.
And so it won't do that. But if I get you can see when I put it out.
The smoke is the part of the wax as it melts.
Right. And so it's really fine particles that are in the smoke, and it makes it catch on fire that way. And fine particles can be really dangerous.
Oh boy, oh my gosh, because that more surface area, as you increase the surface area, you allow particles to mix better, and that mixing creates a more fierce reaction.
Right. So it's like when you start a fire, if you have a fire at home, you don't use just giant pieces of wood to throw in there at first.
And if we had like a little piece of corn and like put it, probably nothing would happen. Right. But if we had some corn starch, holy mackerel, and we did like that, do you have that by the way?
I do.
Oh my, okay.
Or something like it. Go ahead.
Let's try that. So let's look at what happens with increased surface area.
So this is a real fine powder, and it's just like
fine powder
kind of a chemical. It's like kindling. Let's see if we can get it to, well, I'm going to put a bunch in there and then shake it down. And
Oh, yeah, because you got it now. Woo!
so they have to be really careful in places where there's fine powder,
Yes.
like grain silos. Whoops,
Oh
I
my
put it out.
gosh, yes.
And if you're in a place that paints, that if you go to any of the auto body places around, you'll notice that they have special fans
Yes.
that
From the
are-
fumes, the
are- yeah,
fumes.
and they're sparkless.
Oh, yeah.
So that because if you have a spark somewhere and this is in the air, then you can just have this massive explosion.
It smells like sugar.
Yeah.
Is
Get-
it? Powdered
yes.
sugar?
Yeah.
Nice,
it's a-
okay.
it's
Woo now!
That's showing.
Oh, we don't want to burn the ceiling. Nice.
Yeah.
Holy mackerel,
So
that. Look at that.
just shows that the surface area is really important for combustion, and combustion is a fast reaction. 'cause-
Yes. And we can definitely increase the speed of it by doing that.
Right.
Yeah.
And the same with us too. If you think about for food, what our teeth are for is increasing the
Yes.
surface area. So then as we eat it, then
Goes down to our stomach, and the stomach has acids, and the acids can work more effectively if you have smaller particles.
right, lots of surface area. But if
Yeah.
you're cold-blooded,
Or
you
if
can
you're a
just swallow it
dog, I'm just kidding. You know how dogs like swallow
swallow
stuff.
everything, I know.
It's amazing. I
It's
think
just-
they have stronger or some other different kind of stomach
They
acid
must.
than we do.
They're
Yeah.
really
Yeah.
think about
Cats
it.
too. It's like they swallow big
Whoops,
things.
the whole thing. Whoops, I got powder all over the floor again.
Oh well. Heck, we have a vacuum cleaner or a broom.
So
or
then
something.
another demonstration that shows that is that in cars, the engines, what a carburetor does in your car or fuel injection is it sprays really fine
gas.
fuel gas
right.
into your I'm gonna blow this one
Valves?
over. Into your
Right.
engine.
Combustion cylinders.
Yeah.
Whatever.
And it's an internal
Valves.
combustion engine. So and if you ever heard a car without its muffler, incredibly loud.
Oh yeah, it makes a big loud
so-
popping noise.
So
Yeah.
we're going to try the whoosh bottle. today.
Okay.
So
Here, you want me to
so
take this over
is-
here?
Yeah, please. Thank
Okay,
you.
sure. All right.
So what we're doing here is we're going to take a bottle, and this is a isopropyl. This is one not to do at home. So
Yeah, do not try this at
try
home.
to do this at home.
This is isopropyl alcohol,
Yeah.
which, by the way, has a very low vapor pressure. High vapor pressure, which means that, no, low. Okay, well, whatever. Well, what's actually happening is it vaporizes really quickly, much quicker than water does.
Yeah.
So it probably has a high vapor pressure. That's
Yeah,
okay,
and then
somebody
you
can call
you
and
can smell
correct
it
me.
Yeah.
Okay.
You
Yeah,
okay?
all right, so now,
So
look what
so
he
I
did.
is
He
I
coated it.
Yeah, I coated it.
Not that we want to tell you how to do this.
Yeah.
Okay.
And then so I'm going to leave it there for a minute. And then we're going to both stand back.
Oh!
We should get our glasses too.
Glasses, I have them on. Oh, and other kinds,
Yeah,
of course.
safety
Goggles.
glasses.
Goggle glasses.
Just safety first.
Thank you,
as they
safety.
say.
Okay.
And
Okay.
so this is
Goggles
filled with
over
a
the glasses.
vapor, and that's what's happening inside car engines and jet engines and everything else. And then I'm going to try and light it from a distance, and you'll see.
Nice. That worked really well.
Yeah, so it lights it in there, and then you can see, you can hear the whooshing sound.
Yes.
And that's just very, 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 very fine particles. So
Yes. Yes. And actually vapors. So those particles are actually a gas, and that
Yeah.
gas is lighting on fire. So that's why you you don't want liquid gas, like you just said with your carburetor. You don't want liquid to burn liquid gas because that doesn't burn very fast. But
Yeah.
it vaporizes so quickly that you can get the vapor to burn.
Right, very good.
So yeah.
And then one of the other things you can do is we'll try it on here. Actually, can you
Oh, let's
grab
bring
the
it back.
tray,
Of course, the
please?
tray. The magic tray.
So we
Here we
don't
come.
burn the table.
All right, yes.
Is that if I pour this on here,
Okay.
we
And
can
is
light
that
it.
the same isopropyl?
Yeah, I think,
Okay.
and then it has some water in it too, because
Okay.
the water, like you said, and if we watch it burning, you'll see what's actually burning is the vapors, that the liquid's still there. Setting my candle on fire.
Yes.
And
Oh. Okay.
so, and that'll go out. So what I'm
He's
trying to do
suffocating
now-
it. He's
Whoops,
suffocating.
I'm
Trying to
gonna
keep the.
suffocate it.
Oh, hey, look! It's
Whoops.
burning. Okay.
We'll-
Oh dear.
We'll cover that
Oh
up.
gosh.
That'll just go out by
Okay.
itself. Here, we'll see if
Take the
there we
Jepson
go.
manual. No, just kidding.
That one's out.
Yes.
It'll just go out. So,
It
so what's
will.
happening now is you
It's
see
kind of
that
cool.
the
It's a burning tray. The burning tray.
yeah, it's an unexpected
Yeah.
demonstration.
Yes, yes.
So one science demonstration is that you take a $20 bill or a $100 bill or
Yes.
whatever, and
You make sure it's wet first.
right, and light it on fire, and it's flaming, and everybody's freaking out, and then
Yeah.
it goes out, and there's no singe marks on
There's
it.
no singe marks, right? And
on it
that's
at
the
all.
water protecting it, because water
Right.
has such a high surface
Yeah,
tension.
so
or not
it's a
surface tension.
good
Water
one,
has
so-
a high. Oh, it'll come to me. Okay. So anyway, nice.
Now this is another one. There's another cool gas that's quite flammable called acetylene, and they used to use this a lot in miners' lamps, or they still do. That before they had batteries, people who needed illumination to work, like miners who were working underground,
Yes,
would
yes.
use these acetylene
Lamps.
lamps. And so this is called calcium carbide.
Which is kind of dangerous.
Yeah.
Which you don't want to have it hanging around your house.
'Cause
And
it makes
sure you don't.
acetylene.
Yes.
Which
Which they use
is
in welding.
Yeah, they use it in welding very much.
That's a certain kind of welding.
And then I had
not try
water
this.
here. Where's my glass?
Yes. Oh yeah.
And then the neat thing about it is it really, it lights, but it doesn't.
Yes.
So you can see with water, it automatically turns into that, and we can.
What gas is this?
And this is acetylene gas.
Acetylene gas. Right. There you go. You
so-
can see how flammable it is.
Yeah.
Ta-da!
And the way they control it in these little lamps is that you can control the water that goes in.
So there's a whole lot of energy in acetylene because it's C2H2. So we're talking about some really strong. Wait, no, C2H2. I'm trying to think. If there's some more than a double bond or a triple bond involved there. So it's C2H2, which makes sense. There's a triple bond between the two carbons, and then hydrogen is attached to
I'm
each
gonna
of the
try and put
carbons.
This one over here, just to get it out of the way. And then these you might have seen. This is one of my favorites as a kid.
Oh yes. Okay. Do we
is
want? Are
this-
we doing anything with this?
and
No,
we'll
that's
move that
just
out
a
of the way,
show.
yep.
We're showing. Okay.
So we're going to take some more
Moving these
calcium
out of the
carbide,
way.
and there's water in here, and this is called a Big Bang cannon.
Yes.
And
Not the Big Bang Theory. Okay,
and these have
that was
been
a bad
around
joke.
forever. You can still buy them.
I'm putting these on just in case it makes a big noise.
It does make a big noise.
Okay.
So, and we're
I think my brother had one of these
Put
when
a
I was
little bit in
growing
there.
up.
yeah, probably
It was
so.
very exciting.
They
I
still,
don't think we used calcium carbide though.
Huh, I wonder what you used.
Yeah.
And then this has got a little sparker. So
cool.
what I do is I'll hit that, and it'll hopefully light the acetylene. So we're going to let it sit here for a moment.
Nothing shoots out of the cannon, does
No,
it?
I don't think so.
Okay.
But we'll aim it that way anyway. Not at the expense
We'll
of
shoot
cameras.
the camera people.
Yeah.
Just kidding.
We'll
Camera
aim off
people.
there.
Don't worry
Okay,
about
so here goes.
that. Oh my God!
So
Yeah,
that
that
was the acetylene.
Super. Holy mackerel.
Yeah, so that's another fun.
Neat. So we're okay. So what did we use? What ignited the acetylene?
And then there's a little sparker.
Oh, the sparker. That's
so
what
just
you
like
said.
a cigarette
Cool.
lighter sparker.
Got it.
So I'll
Nice.
see if I can zoom in and yeah.
Wow.
So and then that's the
Cool.
smoke that's left over.
The
I guess.
leftover stuff.
I don't know if I won't try to light that.
No, please don't. Who knows what'll
I'll try
happen?
to put that over here with
Okay.
the other dangerous stuff.
Nice. Yes.
Okay. Shall we do it again?
Oh yeah. Oh yeah. Oh yeah. Okay. Okay.
Sam upstairs is telling us to do it again. So
He's our
now I think
producer.
that might be good acetylene. So this one might be very loud. So
Director.
ready? Whoops.
Oh God.
Nope. I guess not. We'll have to,
We need more.
what I'm gonna do is blow
More
out
fuel. Oh,
the
blow
old
on
stuff
it.
because that might just be all the old CO2 and stuff.
Okay. Cool.
And
We're gonna
yeah,
use
it
more.
tastes terrible.
Oh, I'll bet it tastes very
That's
bad.
not what you're supposed
I
to
hope
do.
it doesn't
in
make
a-
you sick.
No, it
Just
shouldn't.
kidding.
Look, there's my pocket knife.
Oh, I'm gonna turn this thing off.
It does smell bad though too, doesn't it?
Okay. Yes, it does. I'm just turning this off so nobody calls.
Okay. Tell you shouldn't be doing that.
No.
And they still sell these Big Bangs.
Wait. What does it say on the side? It says warning.
Warning. It says
Never look into the barrel of the cannon. Do not fire it closer than 2 feet from ears or eyes. Okay. Okay.
So we're doing that.
Good to know. Don't look into the barrel.
And there's a little bit of water in here too. I'm going to add a little bit more.
A little bit of water. Okay. then.
We'll try it. Actually, see if this works
All right.
without it. Okay.
It's
And
okay.
we'll cover that up.
Okay. Do we need
and move
water?
the copy up. I think we're good.
Good. Okay. Great.
If not, if it doesn't work this time, we'll get the
Okay,
water and
we'll
try
find
it
out.
again. Okay. So
Prepare
here
yourselves.
goes. Whoop. Oh, I think I need to add water.
Water.
Okay, we'll try.
Needs water to make the gas.
Right.
But you already know. But
Just that chemical reaction.
Explaining why you need water, because water doesn't burn by itself, but
Yeah,
certainly when you put it with calcium carbide.
Okay. Oh, I see the stuff.
Oh, the gas, and it's coming out the hole at the
Okay, good.
top.
That's a good sign then.
Muzzle.
Now I lost the back of it
It's
there.
not a muzzle.
It is.
It's an opening.
Okay, this one might be louder.
Okay.
So, whoops, I'm gonna pull it back. Okay,
I'm
ready?
really glad I brought these.
Yeah, me too.
Oh, yes.
We'll try and and you can see all the smoke.
Now, oh, it's even burning at the
Yes.
end. Yes.
We'll cover it up.
Don't burn
that way.
yourself.
I'm gonna try and blow through it again to
Oh, dear. Yes.
get the smoke out. Because what happens is all that, like you said, it's all the CO2, and then that stops it from burning anymore.
Right,
which,
right. And that's one of the things, the product of burning is carbon dioxide, and that helps to put
me
out
get
if
the
you
paper
have
towel here,
carbon
sorry.
dioxide. That's why, yeah. Oh, no, well, carbon dioxide not only suffocates fires, but it also can suffocate people.
Right.
So that's why you have a carbon dioxide detector at home, along with your smoke detector, because, wow, these are really good. Really help. I can hear much better now.
Very loud now.
Oh, I have sort of smell of rotten eggs.
Yeah, definitely,
Oh,
definitely
yeah,
has that.
a little bit.
And then
That's sulfur. Wait a minute,
Yeah.
calcium carbide. It is CaC2.
yeah.
Okay, yeah, that's
Okay, we'll try one more time. Ready? Oh, we'll try it. We'll come back to it if we
Nope.
if we have a moment. So,
We did it twice.
yeah, I'm gonna try and
Boy,
suck
we
up my
have
mess.
some fun stuff going on here.
Okay, so another neat one is that you wouldn't think of it, but metals can actually catch on fire.
Yes.
And one camping trick that
Yes.
you might have done is this is just steel wool, which is very fine.
Look at how fine, and look at the surface area here. And the surface areas is how much is actually the surface itself. And notice that there's surfaces all throughout this thing.
Right. So we're going to make a little pile.
Okay, making a little pile. We're not going to burn this top.
No, I don't think. Oh,
Okay.
we'll put it on glass.
All right, good idea. Just in case.
And then
These
so
are very
this
useful.
is
These
a
are
good.
called watch glasses.
Yeah.
Okay.
They look like
Yeah.
the faces of watches.
Face of
and
a
then if I
watch,
just
yeah.
touch this,
Oh,
you can
yeah.
see.
This is a battery that he has, a 9-volt
Yeah, it's just
battery.
a 9-volt battery.
So because we have it's not just a piece of steel, it's
Right.
a steel wool, which is, oh, that's neat.
Yeah.
Look at that. Oh, it doesn't smell very good though. Oh, the smoke. Oh,
Yeah.
but that's beautiful.
It
It's
is. It's
really
like
gorgeous.
And it's a very, very fine texture. So this is a good way to start fires if you're camping too. It just didn't.
With steel wool?
with steel
neat.
wool, so because it's a very fine
That's for
material.
sure. Yeah.
And then just to get your kindling going, and then you can add the bigger stuff all the time.
Neat.
And now a way that they do that, and then another thing, speaking of kindling, is they have
Yes.
these neat thing called magnesium
Oh, yes.
igniters, and this has got a little strip of the element magnesium, and this is a hard metal, and I can, if I strike it, where's that other one at?
I think, oh, yeah. Let's see.
Oh, well, here, I'll take this one off.
Okay. You had one that was, yeah, I don't know.
I probably got it all wet by now.
Yeah, it's
So
true.
if I strike it,
Oh,
then
no, that works.
we get these
That
good
works
sparks.
great.
And the same thing, if you have kindling, you can
Yeah.
get your kindling
Wow,
on
that's
fire.
very neat. So this is a fire starter then,
Yeah.
basically, that you,
So this is from Harbor
Nice.
Freight. Yeah, so
Cool.
they often have them. And then
Yeah.
old school stuff is that before they invented flashlight, or the what are they called on cameras, the electronic flashes, I guess.
Yes, yes.
With xenon tubes.
right.
They had these things, and this is glass with oxygen surrounding magnesium. And then we're going to use,
So magnesium gives up 2 electrons, and, oh no, it accepts 2 electrons from the oxygen, and that creates magnesium oxide. So that reaction is really, you'll see, it's energetic and it produces light. We'll
Yeah.
find out.
so, so I got to connect it, and then if you want to do the honors.
Oh, sure.
Here.
I would love to, thank you.
So, and
Okay,
then
so be prepared, everybody. It's going to be
It'll be
bright.
very
So I'm going
bright.
to put one on the top and one on the side. Oh, yeah.
and you can still see it glowing
Yeah.
in there too. So,
That's really neat.
and then so so you can see how hot it got in there too. It's an
Yeah.
incredibly hot reaction. And so when I done this with my students, they go, "Do it again," and you can't.
You cannot repeat this reaction.
It's a one
It's
shot
like once
deal.
you've broken the egg, you cannot put the egg back together.
Right. So
Yeah.
here's another one. So do you want to do a repeat?
Cool. One more.
And it's very, very hot. So
Oh my God, I looked that time. That is bright, so bright.
I didn't look at it, and I can see I closed my eyes in the
blinded.
there. So
Yes.
that's another amazing reaction. And then one of the tragic things in the space program is that they used to fill the capsules with pure oxygen. I think it was with the Apollos. They were doing a ground test with 3 men in the capsule, and a spark happened, and it caught on fire, and they were gone.
Oh, dear.
They were gone within seconds.
Oh my goodness.
It went up like this.
Well, they should have known, but I mean,
Yeah.
that's very sad.
So, but they were also hurrying. So that's reactions with metals. We'll put that one over here.
Yes.
Now here's a fun reaction that you can.
Yeah, so that metal is doing the same thing that carbon does. It's reacting with the oxygen, but it's not making carbon dioxide and water. It's actually just making the metallic oxide, which is magnesium and oxygen, which is MgO. Do we have a periodic table? Yeah, we did, but that's okay. Don't worry about it. It's all good.
And then you want to talk about hydrogen peroxide?
Hydrogen peroxide, yes. So it's H2O2, and it is not to be drinked. you can swish with it, you can gargle with it, but you shouldn't drink it. But it's an awesome antiseptic. Mm-hmm. It's very good for, well, actually gargling, and especially if you've had work on your mouth and dentistry, it really helps to keep everything so that it heals better.
Yeah. So this is just yeast?
We have yeast, and we have hydrogen peroxide.
And this is a catalyst, and you want to tell them what a catalyst is?
Yes, a catalyst helps the reaction to get started. So a catalyst gets the reaction going, and that's what your, you said carburetor, but I think there's a catalyst in that.
Well, the catalytic converter.
The catalytic converter
yeah,
has the
that's
catalyst,
at the other end,
which is
right.
palladium. What? It's
yeah,
not.
It got all
Platinum?
Yeah, platinum
Yeah.
and all kinds of
Which is an expensive
rare
metal.
earth metals. So.
Yeah.
Okay, so I'm going to add a little yeast on this, and I put a little soap in so that bubbles
yeast.
will form.
Okay.
And then what the catalyst will do is that it will break it down, right? Because the elements that make up, so you can see it's starting to have a reaction. The periodic table is behind
Hey, it's a
us.
periodic table. That's
I
right.
think it's back here.
Here we go. It's right here. No. Oh, I think it's right here. No, it's on the screen. Is it right there too?
I see it.
It's on the screen. No, it's perfect. Okay, so here's magnesium, and here's oxygen over here. These are all the electron givers, and these are electron takers.
Right.
So anyway, you have hydrogen peroxide that is acting as the catalyst
right in there
to get the reaction
and
started.
then so I put some yeast in there. You can also do that with chicken liver, but yeast is a lot more fun to work with than chicken liver.
Chicken liver,
I think it's the blood
smelly.
Blood in the.
Yeah.
So I'm stirring it up, and we should be getting some bubbles forming.
Okay.
I'm hoping. I'm going to raise this.
Oh, I see bubbles.
So people can. Oops.
Definitely see bubbles. Want me to pull it up?
Yes, please.
Okay.
Oh, there we go.
Oh, we got bubbles. Boy, do we have bubbles.
Now there's a thing called the Splint Test.
Yes.
Which is neat. And you want to tell them what the Splint Test is?
The splint. Oh, yeah. The splint test is when you light the splint on fire, that you then push it down into the. And I don't really actually. I know what this is a splint, and I know that this. Go ahead and tell me, because I know I'm lighting it.
What you're going to do, and then she's going to, after it burns a little bit, she's going to blow it out, and it'll just be glowing.
Oh yes, and I'm going to see if it starts going.
Yeah, and then if there's oxygen, it's the new challenge. Now, if there's oxygen, if she goes in there, it will relight. I think we didn't have a good glow.
Oh, good. Not a good.
Let's try it again.
All right. Need more glowing.
Yeah, we need to have it kind of.
That's right.
Let it burn for a little bit.
Okay. Good now?
I think so. Okay, there, nice. Now, if it's oxygen.
Come on, honey. Do it.
Go a little bit lower, I think.
Lower?
There we go.
Like into the.
Not quite.
No, I'm not doing it properly.
That's okay.
You should do it.
No, you're fine.
Okay. I'm burning myself. Here, I can do it with this.
Oh, yeah, that's probably better.
Yeah, that's all right. I mean, I don't know. It's so wet right now.
Well, here, we got another.
Here, let's do a fresh. Fresh.
We brought extras.
Okay, here we go.
So you can see more and more bubbles forming there. We're having a reaction where, and it's breaking apart into oxygen and water. Again, it's that reaction.
Or is it carbon dioxide?
Because
carbon dioxide is not going to light.
Yeah.
But
we want the oxygen. So what we're hoping
you're
is
saying the H2O2 is going to.
Yeah.
Oh, come on, baby. No, this should work. This should work. How come it's not? It's not working.
Let's try it with this.
Okay. Hey, this is the beauty of
this is
science
live TV.
Experiment. This is real, mister.
So there, that. Whoops.
No, almost. It seems like it's not wanting to light.
Maybe this. Let's see. Try
Yeah, there you go.
Well, this should be bursting into flames.
You know what? I thought that yeast made carbon dioxide, but that's
Does it?
Yes, it does. So it shouldn't light, actually.
I think it should.
Okay.
Well, we'll try it.
All right, fine.
Or we might try it again. And
No, it's
without
okay.
the-
I mean,
without
yes.
the,
if you've done it before.
I'm pretty sure.
That's
it's-
awesome.
Let's see.
Okay, it's making oxygen.
Okay, well, while we're doing that, we got
Yes.
one more to set up.
All right, cool. Let's do it. Oh, what about these? Is that
Yes.
what it- okay,
so those
cool.
are the,
All right.
the ones we're going to do.
Here we go.
And then you've seen the colors in fireworks.
That's cool.
And
Yes.
so, oops, set my arm
Oh
on
dear,
fire.
no, no.
Is and the reason that you get all those cool, beautiful colors is because of salts.
Do we need this on?
I don't think so.
No.
No, we can probably
Okay.
blow it out.
Good, great.
So we've got these watch glasses, and then you want to put the salts in them, and I'll put
Yes, I do. Yes,
I'll
I
put
do.
the
This is
alcohol in.
lithium chloride, everyone,
think we
and
can put it on.
lithium's the electron acceptor, and chlorine's the electron donor. Okay, so I'm just putting a little bit in there.
Yep.
There's a little bit right here. Lithium chloride, one more time. Oh, by the way, it's a metal and a non-metal. Copper chloride, cupric, and this is copper, which is the electron acceptor, and chlorine is the electron donor. Okay, and then these are called salts, even though you would not want to eat these salts because this is poisonous, actually, the copper chloride is. And, oh, okay, good, we're getting there. Okay.
And then
And this one was potassium chloride.
Right.
Okay, and then this is strontium chloride.
Ooh, that's my favorite, I think.
Nice. Okay, good.
And I'm using rubbing alcohol, and that'll help excite them.
I think it got a little wet. Okay.
There's a.
Oh, all right.
Oh, that's probably good.
Good enough? Okay.
And then we're going to try and light these.
Oh, boy. Okay.
And hopefully get some cool colors.
Neat. Oh, I can smell it. Once it gets to the salt, it will start, the colors will start happening.
Yeah, so maybe I need to mix them up a
Neat.
little bit more.
Oh yeah, probably. May not have been quite enough.
Yeah, I might have too much.
Come on, strontium. Is that red? Strontium red?
Yes, it's
okay.
beautiful.
Cool. And then
Well,
that should
as
be
we go into, we leave with a flaming, so as we go down, you'll see different colors will start to appear.
once we burn off the
lot of the-
isopropyl alcohol.
Yeah.
And we'll see.
And then this is why, believe it or not, how firework colors work is that you get the different salts, ionic salts, start catching on fire.
There's a
or
burble.
get excited.
Yeah, it's burbling.
Yeah, so there's.
Neat.
And so we'll be back on Thursday.
Yes. Yes.
I'm Ken Pinkerton, retired from Zane Middle School.
Yay, and I'm Pam Halstead, retired from Fortuna High School, and this is very fun. There's a lot of fire and explosions, and it's always that way with Ken, really, actually. Never know what to expect, so it's cool.
All right.
Thank you.
So-
Thanks for tuning in, everybody.
See you on Thursday.